Okay, so we left off on number 2. So this is where the note where it says one side of the equation has to be equal to 0. So the first step we need to do is to add 4 to both sides so that we have 3x squared minus 4x plus 4 equals 0, so that all of our terms are in standard form and our equation is equal to 0. Once both of those boxes are checked, we can identify what A, B, and C are and plug into our quadratic formula. So we will have x is equal to a negative b, so that'll be a positive 4, plus or minus the square root of b squared. B squared would be a negative 4 squared, which is a positive 16. Then our minus 4ac, so negative 4 times a times c. Let's see, negative 4 times 3 is a negative 12, times 4 would be a negative 48. So we have a minus 48 in here. This is all over 2 times a, which is 2 times 3, which is 6. Next, we are going to simplify our radical. So I'm going to combine like terms. Under the radical, 16 minus 48 is a negative 32. And this is all over 6 still. We are going to break apart that radical 32. And that will be, well, we definitely have the negative 1. The 32 can be broken into a 16 and 2, which technically you could stop right there. We know the square root of 16 is 4. However, if you did your factor tree differently and kept breaking this apart into like a 4 and a 4, and then a 2 and a 2, we would have a pair of 2's, or 2 pairs of 2. So we would have, let's see, let's copy over what we do have. 4 plus or minus. We have 2 pairs of 2, so we multiply that together and it becomes a 4. We have, let's see, the negative 1 is our I. And then we have a 2 left over inside. Then we are going still all over 6. And our very last step is just to make sure that we can't reduce this any further. When we're looking for what can be reduced, you're looking at the coefficients. You don't worry about the I, you do not worry about the radical. So looking at 4, 4, and 6, these can all be reduced by 2. So 4 divided by 2 is 2. 4 divided by 2 is another 2. The I and the square root of 2 stays the same. And 6 divided by 2 is 3. And this would be our final answer. Okay, the next two, I would encourage you to try these on your own. They do look differently, so maybe just watch me get them started, pause the video, and then do the problem, and then check your answer with me after. So for number 1, we have all these fractions, so I would get rid of all of our fractions in the first step. We're going to think of the least common multiple of 2 and 4. So the smallest number that 2 and 4 both go into would be 4. So we're going to multiply everything by a 4. So 4 times 1/4 is 1, so we're just left with x squared. 4 times a negative x is a negative 4x. 4 times 1/2 is 2. And 4 times 0 is 0. Now we don't have any fractions, and we can do the quadratic formula like we did in the last problem. So again, I would encourage you to pause the video, try it on your own, see if we get the same answer. So our a, b, and c are the coefficients. We have an a of 1, b of negative 4, and a c of 2. So our quadratic formula says x is equal to a negative b. If we have a negative 4, a negative 4 would be a positive 4. You always just flip the sign of whatever b is for that first term. Plus or minus the square root of b squared. Negative 4 squared is 16. Then we have our minus 4ac, so negative 4 times a is negative 4 times 1, and c is 2. So negative 4 times 1 is a negative 4, times 2 is a negative 8. So we'll have a minus 8 in here. all over 2a. 2 times 1 is 2. So I like to do a lot of the math in my head or, verbally out loud, just so that I don't have to write down all of these steps over and over and over again when I can just combine things in my head and save myself from writing them. Okay, so we have 4 plus or minus, simplify our radical, 16 minus 8 is 8, all over 2. We will break apart that radical. Sorry, it's so large. 8 can be broken into 4 and 2, which we know the square root of 4 is 2. But if you like the pair thing, that works as well. So we'll have 4 plus or minus. We have a pair of 2's. We have this 2 left over. And this is all over 2. So we need to look to reduce. These can all be reduced by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1. So I'm just going to leave it as square root of 2. There's no point in writing a 1 right there. And it's all over 1, which again, dividing by 1 doesn't change anything. So we're just going to drop that, and we have 2 plus or minus the square root of 2. So for our next problem, looking ahead, this is not equal to 0, and we also have that binomial raised to the power of 2. So we want to start actually by foiling out that y plus 2 times y plus 2. So we'll have y times y is y squared, y times 2 is 2y. 2 times y is 2y, and 2 times 2 is 4. And this is still all equal to the 2y that we have below. We can combine like terms. We'll have y squared plus 4y plus 4 equals to 2y. Subtract 2y from both sides. And we will have y squared. 4y minus 2y is 2y. Bring down the plus 4. And this is now equal to 0. So we are all set up to do our quadratic formula. We have a equal to 1, b equal to 2, and c equal to 4. So now that we've done some of that setup work, I would encourage you to pause the video and try it on your own. So we'll have x is equal to a negative b, so that would be a negative 2, plus or minus the square root of b squared, which if b is 2, b squared would be 4. Then off to the side, I'll show my work for the minus 4 times a times c. So that would be negative 4 times 1 is a negative 4 times 4 is a negative 16. So we'll have a minus 16 right here. And this is all over 2 times a, so 2 times 1 is 2. Then in our next step, we simplify inside the radical. 4 minus 16 is a negative 12, still all over 2. And we need to break apart that radical. So we have a negative 12, so we'll definitely have a negative 1 and 12. Then the 12 can be broken into a 4 and a 3. So let's get this stuff ready. So we'll have negative 2 plus or minus, and still all over 2. The negative 1 means that there's definitely going to be an I. We know that the square root of 4 is 2, and we'll have a 3 left over, which you'd get the same answer if you recognize that 4 can be broken into 2 and 2, so you have a pair of 2's and it would come out. That's why we look for pairs, because it creates a perfect square. And our last step, we need to look for a way to reduce. So we're looking at all the coefficients, which they're all 2's, or we have the negative 2, so they can all be reduced by 2. So our final answer is a negative 1 plus or minus. 2 divided by 2 is 1, so we're just left with I root 3. All over 1, dividing by 1 doesn't do anything, so that's going to be our final answer. Okay, so we can also use the quadratic formula to solve real-world problems. So this scenario right here is talking about living on a golf course on a corner lot. Often golfers cut across his lot to save walking distance. I am not going to go through and do this problem. I did not do it in class. So if you want to see this problem worked out, you can go see Algebra Nation for that. However, I do want to talk about this recall, and this is all to section 4, topic 1, where we talked about the real world applications of quadratics. So quick refresh, ax squared is representing gravity, bx represents velocity, and c is representing initial height. And now what gravity is depends on if your word problem is in feet or in meters. So you'll want to look out for that when you're reading the word problem. So for this problem, we are told that the lower falls in the Grand Canyon have a height of 308 feet. A pebble is thrown upward from the top of the falls with an initial velocity of 15 feet per second. Assume there is no air resistance. How many seconds will it take the pebble to hit the ground? So we're going to have our function, which is height over time, will be equal to gravity, which in our problem we're talking about feet. So our gravity is going to be 16 feet per second squared, or just 16x squared because we are in the A term. Then our bx is our initial velocity, which they said was 15 feet per second. So we'll, wait, this is what's wrong. We're talking in terms of time t, so it should be t squared plus 15t. That doesn't really affect anything. It's just a formality. And then plus our initial height of 308 feet. I do have a mistake in here. My mistake is that in this right here, we said gravity is negative because it's resistance. So this should be a negative 16. I just want to make sure that gets changed on your paper. The final thing that we need to make a note of is that part A is asking when it will hit the ground. So that means our height is going to be equal to 0. So we'll keep that in mind before beginning our quadratic formula. So we'll definitely still have an A equal to a negative 16, a B equal to 15, and a C equal to 308. So I would encourage you, now that we've set this problem up, to try it on your own. And the answer will be in the next video.